Okay, here we go again. Now this is the last session before we finish chapter 4. So there's 9 chapters in total, and so we're nearly halfway through, which is really good. And this is not too long, and it's just a little bit more of an advancement on what you've already done at GCSE. So I think you'll find this one okay. And let's go straight in. Solving simultaneous equations with 3 unknowns. Okay, so I'm going to go straight in with an example. And you would have done 2 unknowns at GCSE level, probably even earlier than GCSE. But this time we're going to have 3 unknowns, x, y, and z in this case. So the question might be solve the following. So solve the following. So this is one equation, the second equation, 3x minus 21 minus 2z, and the third equation. Now, because you've got 3 unknowns, you must have 3 equations, different equations, otherwise you can't solve it. Okay, so there's the question, probably 3 or 4 marks. I approach it how I would normally. So I'm going to label the equations 1, 2, and 3. Now this is what I'm going to use a substitution method here. So I'm going to rearrange 1 to get z equals something. Now if I rearrange 1, I just need to add 8 to both sides. I'm just going to add 8 to both sides and I get that equation, okay, for equation 1. That's a rearrangement of equation 1. Okay, so that's a rearrangement of the first equation. I'm now going to substitute that, so sub 1, the rearrangement of 1, into equation 2. So wherever I see a z, I'm going to take the z out and I'm going to put in that, because they're exactly the same. So I can say 3x minus 21 equals 2y plus 2, take the z out, and 2x plus 3y plus 8 in instead of it. Just going to tidy this up a little bit. Multiply out brackets. Okay, tidy it up a bit more. 3x minus 21 equals, that's going to be y. And I end up with 7x on that side, plus 4y's on the left hand side, and that's going to equal 5. I'm going to call that equation, not equation 2, we've already used that. I'm going to call that equation 4. That's my new equation. Okay, so I've generated one that doesn't have z's in it at all. Now I'm going to sub the same one, but into the bottom equation 3. So I've substituted it in here. I'm now going to create another equation by substituting it in there. So I've rearranged the first one, I've substituted it into each one. So let's see what we get if we do that. 2x plus y, 2x plus y equals 3. I take the z out and I put 2x plus 3y plus 8 in instead of it. Minus 4. Let's be careful. Multiply this out carefully, not making any silly mistakes. Okay. Rearrange it, so I'm going to get minus 4x, that gets rid of the x's, minus 8y, that gets rid of the y's, equals 20. You can divide it all by 2, minus 2x minus 4y equals 10. I'm going to call that one equation 5, okay? So I've now got equation 4 and equation 5, and there's no z's there. So now I can do, as usual, what I normally do is just solve those normally. So I'm going to put equation 4 underneath it. And plus 4y equals 5. As you can see, the equations already have y's with a common value there. And because it's a different sign, I just need to add them. So I end up with 5x equals 15. X is going to equal 3. So I've got x straight away. And then I'm just going to sub into the easiest one. So sub into maybe equation 4. So I get 7 times 3, 21, plus 4y equals 5. 4y equals minus 16, y will equal minus 4. So I've got the second one. And then I need to sub into one that has a z in. So sub into, let's go right back to the top, maybe sub into 1, the rearrangement of 1. So sub into 1. Z was equal to, remember what this is, 2x plus 3y plus 8. 2x plus 3y plus 8. So it's going to be 6 minus 12 plus 8. Z is going to equal 2. So my final answer is x equals 3, y equals minus 4, and z equals 2. And I would do a check. So let's check in maybe equation. If I had time, I'd check in all three, but check in equation 2, which is right back at the start. So right back at the start, 3x minus 21. So 3x minus 21 equals, let's see what it was again, 2y minus 2z. 2y minus 2z. Let's just see if that works. 3 times 3 is 9 minus 21. Does that equal minus 8 minus 4? Yes, it does. They're both going to equal minus 12. So I know that that is correct. Okay, so that's my answer there. Right, that is basically the whole chapter. I'm going to do one more example, which is a little bit of a sort of relates to sequences, but it's exactly the same style. So EG2. Okay, so 0, 3, 10 are the first 3 terms of the sequence an squared plus bn plus c. Okay. Part 1, set up 3 simultaneous equations with A, B, and C. And you might want to pause the video at this point and have a go at that yourself. So set up 3 simultaneous equations with A, B, and C. Right, what this means is if I read the question carefully, I know when n equals 1, the first term, I know that u of 1, the actual term, is going to be 0. That comes from there. So this is when n equals 1, that's going to be when n equals 2, and that's going to be when n equals 3. My first equation, I just need to substitute 1 in here. I get a 1 squared plus b times 1 plus c, and that's going to equal 0. Okay? Let's do when n equals 2. So the second term, when n equals 2, the second term is actually 3. So if I put 2 in here, I get a 2 squared plus b times 2 plus c, and that equals 3. That's my second equation. First equation, second equation, and third equation. When n equals 3, the third term, u3, is going to equal 10. So I get a 3 squared plus b times 3 plus c equals 10. That's the third equation. Okay, right, I'm just going to tidy all these up. So the equation number 1, that just turns out to be a plus b plus c equals 0. Equation 2, 4a plus 2b plus c equals 3. That's equation 1, that's equation 2. And equation 3, 9a plus 3b plus c equals 10. Equation 3. That's my part A. Part B might be to solve the equations. Solve the equations. Now I can do this like I did for the other question, where I rearrange one to get A equals or B equals or C equals. But I can make it a little bit easy for myself, because I know that 1 and 2 both have a C in common. Because they have a C in common, I can do elimination immediately. So I can do equation 1. Actually, I'm going to do equation 2 minus equation 1. Now, if I do 2 minus 1, I get 3a. 4a minus a is 3a. 2b minus b is b, the c's disappear, and that equals 3. So that's equation 4. And I can do something similarly with 3 and 2 because 3 and 2 also have a common c value there. So I can do equation 3 minus equation 2, and this time I get 5a plus b, c's disappear, equals 7. I'm going to call that equation 5. And again, I can solve this quite easily by just doing equation 5 minus equation 4, because the b's are going to cancel then. So I just get 2a equals 4. Straight away, I know a is equal to 2. Let's sub into equation 4 maybe. So I get 6 plus b equals 3. B is going to equal minus 3. That's my second one. And then finally sub into equation 1 right at the start. A plus b plus c is 0. So 2 plus b plus c is 0. C is going to equal 1. Okay, and my answer, because it probably wanted me to actually say what the equation was, it's an squared, so it's going to be 2n squared. The nth term is 2n squared minus 3n, because that's what a was, that's what b is, and c is 1. That's my equation for this sequence. Okay, right, that is it for examples. I want you to have a go at it's exercise 4k, and I just want you to do question, well, it's on page 118, questions 4 to 8, please. Okay, and well done, that is chapter 4 finished. So we will moving on next time, but that is a really good, we're about halfway through the course, so well done guys, and keep going.